Welcome to ViaCon's latest discussion about geological phenomena, such as landslides, their causes, and how environmental and climate change affects the frequency and severity of these events. My name is Peter Cederqvist. I am working as a director for Geotechnical Solutions in the Nordics for ViaCon. And joining me is our guest and my friend Fredrik Thellbro from AFRY. Welcome, Fredrik.
Thank you, Peter, and thanks for the invitation to this talk.
Fredrik, you have quite a long background with this, 20 years from the industry. You have been with AFRY for, 5 years, the past 5 years, serving as section manager for the Department of Geotechnical Engineering for the northern part of Sweden. Your field of expertise and work areas are all kinds of geotechnical questions related to built environment, such as what do we have? Roads, railroads, buildings, mines, power lines. Do I forget anything?
I think you guessed it quite well, Peter.
Great to have you in this talk. When pitching into this talk, we have referred to the occurrence of landslides as a phenomenon and why they happen and how they happen. When landslides occur, we know that it is a result of a multiple set of actions setting in areas where the soil conditions are less stable, the risks are significantly higher. For example, one recent landslide event on the Swedish west coast, an area known for soil conditions containing something called quicklay. Quicklay is normally quite stable, but becomes highly unstable when exposed to vibrations, high loads, and higher groundwater levels. And when quicklay loses its stability, it liquefies, and the natural force between the particle in the quicklay disappears, and larger landslides may occur.
Yeah, exactly.
When events like these happen, it may often have huge impact on the society and the economy. When large sections of motorways and country roads closes down for long periods and our important flows of goods and people are forced to take other routes, it impacts our society and our economy.
Yeah, and it can have quite negative impacts.
Yeah, indeed. Fredrik, we can see similar stories in the news with growing frequency. But let's start by talking about what we can do to fight against the negative effect of climate change. How are we currently planning technically for civil engineering as a means to not only build sustainable infrastructure, but also to build things to last in the face of environmental changes?
Well, these are all very big questions, Peter.
Indeed, big questions, but also raised by many, of course, in our society.
Yeah. Well, within AFRY, we have engineers working to mitigate the effects of climate change and to work proactively with this. We also have engineers working fully with urban and rural planning for the government and the municipality, and also engineers working with detailed design for specific solutions. But if we talk a little bit about the phase planning and design relating to geotechnical problems, there are standard and guidelines to follow. And these documents have evolved over a long time to fit our geology and design approach. But the question is if are we adapting to the ongoing climate change, and can we foresee what is to come in the future?
Would you say that the standards and guidelines are subject to change in order to mitigate the effects of environmental change? When we plan the big buildings and infrastructure projects?
Not necessarily. The standard and codes used today may continue to serve us in the future. They're also revised every now and then. But not all aspects of problems will be dealt with within the code. Looking at where we are today with recent heavy rainfalls, that could be an effect of climate change. We may have to consider this when we're using the existing code, since water and groundwater have huge impact on stability of the ground. And another aspect, not really related to the side effect of climate change, is that in our need to further develop and consolidate urban areas, we are planning, designing and building in areas of land that before was earlier deemed as unbuildable. For example, this could be areas with soft ground not fit for heavy loads.
Really interesting perspectives. Is it by that reasoning fair to say that we have higher risks for pitfalls in our planning if we do not carefully, consider the possible effects of climate change, such as heavier rainfalls?
Well, looking at slope stability, for example, there are a few key parameters that are crucial to consider: geometry, soil properties, and water. These are all familiar things that you already work with, Peter, at ViaCon.
Yeah, true.
Geometry, the angle, height, and overall shape of slope are critical factors. It's a steeper and higher slope are generally more likely to fail. And the soil properties, understanding the type of soil, its strength, and its structure is fundamental. Parameters like cohesion, internal friction angle, and permeability significantly influence stability. And then water significantly affects slope stability. The presence of water can reduce the soil strength, but also increase the weight, and that leads to a higher risk of slope failure. And we are good at determining the geometry of slope. It's easy today with precision GPS instruments. And also soil properties, they are evaluated from different methods during the soil investigation.
So are you saying that in general that the slope angles and geometry are rather easy to determine, and finding the soil properties is something the industry is rather good at? But I'm thinking, like, how can we be sure in getting the water levels right then? And do we measure water levels over time, for example?
Well, that is actually quite tricky. If you only have one reading and base your stability calculations on that, you could be way off, because the water levels have a big impact on stability. So it is important to conduct readings of water levels for a longer time, preferably a whole year. That way, the variations during the year can be noted. And depending on the soil, there are different ways to measure this, but it is important to get it right. And I think in the effect of climate change and the change of precipitation needs to be considered more. And one way of doing this is to elaborate more with the sensitivity analysis regarding the water level.
All right. But how do we normally do today when it comes to measuring the groundwater levels and the values used in stability calculations in civil engineering?
So a lot of projects are based on short-term readings of water, not enough measuring points. And depending on the soil and geometry, that could be okay. But if climate is changing, we may not evaluate the most likely outcome or even the worst case. And this could lead to slope failure.
Do you think that we will see any preventive measures with respect to those factors? Or can we say that there are systems already in place to some extent?
Yeah, in our codes and guidelines today, we have minimum requirements for investigation. That would translate into data for evaluation of the slope stability problem. But it is important to create an understanding with our clients about the risks if the specific problem isn't handled the right way. And looking at water again, it is important to get the right range of variation of water level to find the worst case. And this can really be improved, in my opinion.
Would you say that the industry share your opinion on this? And would the codes and standards be revised with respect to your opinion?
Well, I hope the industry shares my opinion and that we can work proactively together on this. The thing is that the codes and standards that we use today within the geotechnical area do not really handle groundwater levels. Why we would need to develop some guidelines and standards to help the industry to deal with this matter.
All right, let's see if that interesting opinion comes true. Do you see other preventive measures taking place?
But depending on the specific problem, there are ways to deal with water. For example, water could be diverted early from reaching the site with drainage and ditches. This is of course done today, but in some areas the diverting capacity may need to be increased or even maintained in a better way.
Interesting point. We had actually quite recently a full stop on the railway line along the Swedish east coast when the railway embankment was partly washed away, and where the identified root cause of that problem was a clogged culvert under the railway. In my view, that is partly a maintenance issue and maybe not something to dig deeper into in this discussion, but maybe it could be a subject for a separate talk. But with our reasoning till now, I am under the impression that the industry in general is aware that we need to do things differently rather than continue on the same route. With respect to the climate change. Do you agree on that?
Yes, in some ways, the industry is aware of the problems, but we can do more, definitely, both in this specific case and as well as on a larger scale.
Yeah, we have talked a bit on some specifics during our talk today, which have been great. And I think we can agree that there is a lot that can be done to design more sustainable, responsible, and lasting solutions that take the changing world into account. Fredrik, before we wrap up this discussion, what would you say are the key things we can do to prepare ourselves better in dealing with landslides?
With civil engineering, it is critical. We need to build lasting infrastructure that is used for generations. As we say at AFRY, we are making future, not just for us, but for all generations to come. We don't want to continue rebuilding these massive projects over and over because it's wasteful and destructive to society. But that's just one aspect of sustainability. Now it extends to also understanding the sensitivity and conditions of the land on which we build, and being able to ensure that the ground we build on is as sustainable and stable as the construction we build.
I could not agree more. Thank you, Fredrik, for this immensely interesting and very insightful discussion today. We will continue to have similar discussions with more experts about topics related to sustainable civil engineering and infrastructure construction. Keep following us for more. And please let us know if there are other such topics you'd like us to dive into. Thank you for joining us in this discussion.